This video is an introduction to ClickHouse for Postgres developers. Let's start by comparing the two databases across some high-level aspects. So we'll start with workloads. So for Postgres, that's going to be transactional workloads, whereas for ClickHouse, it's more analytical. In terms of data storage, Postgres stores this in a row-based format, whereas ClickHouse stores data in columns. Data access patterns. So with Postgres, we'll typically be doing single row lookups and maybe small range scans, whereas in ClickHouse, it's more typical to do aggregations on a subset of columns. With updates and deletes in Postgres, they'll be immediate and in place, whereas in ClickHouse, it's append only and it will then be eventually consistent. And the typical use case in Postgres, it's CRUD operations, whereas in ClickHouse, it's typically large-scale analytics. Both databases store data in tables, and each field has a type. There's a mapping from most Postgres types to ClickHouse types, but they do use slightly different names. There are some differences in how we configure tables in ClickHouse and Postgres. So when it comes to indexing, in Postgres, you might typically use a B tree, but there are other indexes supported. Whereas in ClickHouse, we have the concept of a sparse index, where only the first row of a granule, which is like a subset of the data, will be indexed. For primary keys in Postgres, that's used to ensure uniqueness, whereas in ClickHouse, it's used to define the columns that are going to go into that sparse index that we just talked about. Data sorting in Postgres is in insert order, and we don't really need to think about that. Whereas in ClickHouse, it is quite an important thing, and so we need to focus on our sorting key. Table engines in Postgres, we just have a single one, whereas in ClickHouse, there are a wide range of engines to do different things. And then finally, null handling. So Postgres has native null support, whereas in ClickHouse, we need to use the nullable type. The contrasting strengths of Postgres and ClickHouse create an ideal pairing for modern applications. Our data will begin its journey in Postgres, where our application handles transactions. So for example, we might have a table like this users one, and you see it has an ID as a primary key. We have a reputation, we have a creation date, display name, and a bunch of other fields as well. To make this data available for analytics in ClickHouse, we need a way to sync changes in real time. A technique called change data capture has emerged as the way to do that. There are many products for doing change data capture, both open source and commercial. I'm a bit biased, but I'd recommend using PeerDB if you're running ClickHouse yourself, and Postgres CDZ via ClickPipes if you're using ClickHouse Cloud. Now let's have a look at the definition for that same users table in ClickHouse. As mentioned earlier, ClickHouse has the concept of table engines. We'll be using the replacing merge tree engine, which allows us to handle updates. This table engine removes duplicate entries with the same sorting key value. It will keep the row that has the highest version. Data is still appending into the table, but in the background, a merge process is running, and that will take care of deduplicating the data. We also specify an order by expression, which controls the order in which ClickHouse sorts the data. We'd usually choose a field or fields that we're going to be querying a lot. The three fields with the underscore PeerDB prefix are used to track various metadata around the CDC process. This diagram here gives a conceptual understanding of what's happening when you use Postgres CDC in ClickPipes. Step 1 shows the initial snapshot of the two rows in Postgres and ClickPipes performing the initial load of those two rows to ClickHouse. Both rows are copied as is to ClickHouse. Step 2 shows three operations on the users table. So we've got inserting a new row, updating an existing row, and deleting another row. ClickPipes will consume those operations from Postgres' logical replication slot. It's not shown in the diagram for simplicity's sake, but this data is written into an S3 bucket before being ingested into ClickHouse as versioned inserts in step 3. Let's zoom in and put the Postgres and ClickHouse queries side by side. So we can see the initial insert is pretty much the same on each side, except the ClickHouse query has some extra metadata. The update statement appears as a new version of the row with ID 2, and the delete appears as a new version of ID 1 with is deleted marked as true. Because of this, ClickHouse has 3 additional rows compared to Postgres. If you want to see all of this in action, check out this video next.